Okay, so we're beginning chapter 5 today. So chapter 5, we have finished it in a in a lecture, I think 2 weeks ago. So today we're going to do exercises, okay, do a practice on chapter 5. Yeah. All right. So let's recall what is the equations for work done. Now, 5.1, apply work done by a constant force and also from a force displacement graph. So by constant force, now what is the equations if you remember? So work done, the definition is W equals to F, oops, okay, F dot S. It is a dot product. Now, when you have a dot product, you are going to change it into a cos function. Okay, so it becomes Fs cos theta. So you have to understand what is the meanings of every single term. Now, this force, okay, of course, F is a force, and then S is the displacement. Okay, displacement. And then what is the angle? Now, angle is the most important part in these equations, actually. It tells you the angles between F and S. So you need to know how to determine the angle. So sometimes students, they like to resolve force first. Okay, let it force on the same axis as the displacement. Then in that case, what is the angle? Okay, we'll try the questions later. And then the second part of this 5.1 is apply work done from the force displacement graph. So when you have a force and displacement graph, okay, force against displacement graph, which part of the graph represents the work done? Okay, obviously is area under the graph. Okay, so we have area under the graph represents the work done. So let us begin exercise 1. Exercise 1 is the most fundamental exercise in chapter 5 for work done. Okay, we will see how to determine it, how to calculate the work done. So first diagram. First diagram, you have a force going to the right and then S also going to the right. So we know that W is not a vector, yeah? Just now I make a mistake. Okay, it shouldn't have arrow because it's not vector. Okay, so W equals to Fs cos theta. So given force is 5 Newton, S is 10 meter. So both of them, they are already in SI unit, so you don't have to do anything about it. So force is 5 Newton, and then S is 10 meter. Now, both of them, they are pointing towards same direction. Okay, so if you are heading towards same direction, then angle is 0 degree. Okay, so same direction, 0 degree. So which is then equals to 50 joule. Okay, so how do I know that it's 50 joule? Because cos 0 is equals to 1. So this is the things that you need to know when it comes to trigo functions, because objective questions, they like to ask you which situations give you maximum work done, which situations give you minimum work done, which one give you maximum value, which one give you minimum value, and so on. So all those you need to know. Okay, you can tell directly based on the angles given. So cos 0 is equals to 1. Cos 90 is equals to 0. Cos 180 is equals to -1. And then sine 0 is equals to 0. Sine 90 is equals to 1. So all this, basically, you don't need to press calculator at all, okay? You should know the value straight away based on the diagrams given, based on the free body diagram that you sketch. All right, let us move to a second questions. So second questions, now I have a force that is going up, 60 degree above horizontal, and then I have S. I'm going to show you both methods so that you don't get confused when you look at revision's book. Okay, so it's up to you which one you want to use. All right, I won't force you to follow my method. What I want to tell you is, I have two methods to solve this question, and it is up to you which one you want to use. All right, I just don't want you to get confused, because nowadays you got a lot of YouTube video, and then you got a lot of revisions books. All of them, they use different method. Okay, so make sure you know both of them. Both of them, they are correct. All right, both of them, they are correct, just that the ways they solve it is slightly different. So I'm going to show you the first method in a red color ink, and the second method in a green color ink, right? So first, okay, straight away you can apply W equals to Fs cos theta. Okay, so your force given is 5, and then S given is 10, and angles given is 60 degree. So straight away, you just substitute into the equations, and you are going to get 25 joule. Now, there's another method that the people like to use, okay? They resolve F into Fx. Because when you resolve F into Fx, it will be pointing towards the same directions as S, okay, as your displacement. So they resolve it, okay, but they just ignore Fy, they take Fx. So if you're going to take Fx, then what are you going to do? So you will have W equals to Fx as, still you have to write cos theta because it's part of the equation. So Fx, what do you have? You have 5 cos 60 degree, and then times with the 10 meter. But now this cos theta, you will have a second cos theta. This is a second cos theta. Now you look at Fx and also S. Okay, so Fx and S, they are now pointing towards same direction, therefore cos 0 degree. So basically, now the functions of the second cos, it just tells you whether you have a positive value or a negative value. Cos 0 means this, it will give you a positive value. Cos 180 means you're going to get a negative 1. So especially when it involves friction, you use cos 180 degree. So eventually, you're still going to get 25 joule. Okay, the only difference now is that it resolve. Okay, it resolve Fx. It resolve force into the x component first, so that the force is pointing towards the same direction as your displacement. So this method, usually we use it when we calculate total work done. Because total work done, you need to use net force. Okay, so if you recall the things that we learned in lecture, W equals to Fs cos theta. This can be used for any force. Okay, this force, it can be any types of the force. Okay, any types of force. But if you're going to calculate W total, then F need to be F net, which is your resultant force. Okay, so Fs cos theta. So this one is your resultant force. So when it comes to resultant force, then most of the times we use the method in green color. Okay, because it will be hard for you to calculate individual force. Okay, to assume it as an individual force. So most of the times you will use the second method. But anyway, both of them, they are correct. So it is up to you which method you want to use. All right. So I introduce both to you because a different reference book, they shows you different method, different YouTube video, they shows you different method. Therefore, I show you both. Okay, I don't want you to get confused. So make sure you take note. Okay, now question C. Question C, now you have a force that is going up and S going to the right-hand side. So what am I going to do? W equals to Fs cos theta. Actually, these questions you don't even have to calculate, but still you have to show it. Okay, so W equals to 5, 10, but now cos 90 degree. Okay, which then give you 0. Why? Because I told you just now, cos 90 degrees straight away equals to 0. So that's why you don't even, I say you don't even have to calculate, because it's equals to 0. So sometimes subjective questions, they give you questions like this, but then they didn't give you the information about the force, or maybe they didn't tell you the displacement. Then they ask you to calculate work done. A lot of students, they say, oh, miss, I don't have enough information. I don't have force, I don't have displacement. How am I going to calculate? Do you need to calculate? No. Why? Because angles already tells you the value is equal to 0. Okay, so this plane, okay, this five value, they are very important. So make sure you memorize all of them. Okay, it can save a lot of time. All right, next questions. So next questions, okay, again, I have a F, and then I have a, okay, I have angles, and then I have a force, but now force is 120 degrees from the positive x-axis. Okay, so what am I going to do now? Now, when it comes to these questions, usually we take the value between 0, okay, until 180 degree. So as long as it is still in between this 0 until 180 degree, then we take angle equals to 120 degree. Okay, it is unlike our resolving vector. Resolving vector, we take the angle in between 0 until 90. But when it comes to a dot product questions, in a work done, we take the angle in between 0 until 180 degree. It could be in the clockwise direction, it could be in the anti-clockwise direction. All right. So again, I'm going to show you two methods, okay, both method. Method 1, very simple. W equals to Fs cos theta. Again, my force is a 5, and then my displacement is 10 meter. And then now my angle is 120 degree. Okay, you don't take 30 degree, you take 120 degree. Okay, you take 120 degree. So which is then equals to negative 25 joule. If you take cos 30 degree, not 30, yeah, cos 60. If you take cos 60 degree, then you are going to get positive 25 joule. All right, so we take 120 degree. So even though we know from here is 60 degree, but we don't use this 60 degree. We have to start from the line, okay, from the axis that is pointing, that is parallel, that is in the same direction as our displacement. So displacement going to the right hand side, your angle need to be start from displacement. Therefore, from displacement, okay, from displacement, you count the angles. So until force is 120 degree. So angle always start from displacement, okay? So if your displacement is going to the left, for example, now if you have S going to this direction and F going to this direction, then you start from here. Then it will be 60 degree. Okay, but now you have a force going towards the left-hand side, S going towards right-hand side, so you need to calculate from right-hand side. The angle should be start from positive x-axis. Okay, so this is how we calculate the angle. So force work done actually is very simple. Okay, this subtopic. The only problem is students don't know how to determine the angle. Right? So now let's look at the second method. Now, if you have a questions like this, how are you going to apply second method? Okay, so again, W, let it be equals to Fx as cos theta. So now if you resolve Fx, so Fx would be going to the left-hand side. Okay, so Fx is F cos 60 degree. So 5 cos 60 degree. And then times with S, which is 10 meter. But now your cos is no longer 0 degree. Why? Because if you look at the diagram, Fx and my S is now pointing towards opposite direction. So cos 180 degree. Okay, and it is equals to negative 25 joule. Now you obtain this negative because cos 180 degree, it gives you negative 1. All right, so 5 cos 60 times 10 give you 25 joule, but then cos 180 degree give you this negative sign. So this negative sign is coming from cos 180 degree because now your Fx and your S, they are pointing in the opposite direction, towards opposite direction. All right, so this is the fourth questions. Now let's look at the fifth questions. Fifth questions, okay, this is very simple. So W equals to Fs cos theta, so which is then equals to 5 times 10. Now you look at the diagram. Okay, they are pointing towards opposite direction. One going to the left, one going to the right. So straight away, cos 180 degree. Therefore, it is equal to negative 50 joule. Okay, negative 50 joule. So this is how you solve these 5 questions. This is how you calculate work done according to its component, right? So now I give you 2 minutes to write it down, okay? I give you 2 minutes to write out everything, including the cos 0 degree until a sine 90 degree. What is the values that you're going to obtain? So that you can, sometimes you can straight away answer the questions without any calculation. Okay, so angle plays a very important role in this chapter. Make sure you know how to determine the angle. So 2 minutes from now, if you have any questions, you may ask. Okay, so now I want you to try the next question first. Okay, next question is a very simple question. Right, so you try to identify the force first. I would encourage you to sketch free body diagram. So you sketch free body diagram, and then from the free body diagram, you will know how to calculate the questions. Okay, so I give you 1 minute to try it. This is a very simple questions. Okay, 2 minutes because you got quite a lot of work to calculate actually. But it's very similar to the one that we just discussed. Okay, so you need a free body diagram. Get a free body diagram first.
Madam, ada orang
Yep.
tak boleh masuk.
Ada orang tak boleh masuk.
Ha.
Siapa yang tak boleh masuk ini? Kenapa dia tak boleh masuk?
Sebab tadi phone dia hang, termati.
Oh, so dia sekarang kena restart dia punya phone.
Dia kata dia tengah tunggu Madam approve.
Tak ada pun?
Oh, tak ada.
Dah boleh dah, Madam.
Tu dia. Okay, so start from a free body diagram, yeah? Sketch a free body diagram first. All right, let's see. So now you push your physics reference book 1.5 meter along a horizontal table with a horizontal force 5 Newton. The frictional force is 1.6 Newton. Okay, so how to sketch the free body diagram. So now this is your object, which is the books. You push the books, let's say you push it to the right hand side. So this is your external force. And then it experiences a frictional force. So frictional force obviously is in the opposite direction. So frictional force. Now book is an object. Every object comes with weight. So weight is going down. And then you place it on a table. So it means it is in contact with a surface. Therefore, there is a normal force that is pointing up. Okay, so we have 4 forces acting on the book right now. So you see, even though you're just pushing a book on the table, but wow, there are so many forces acting on the book at the same time. Okay, can imagine, right? So now A, calculate the work done. Okay, if you look at the questions, how many types of work done at once? 5 Newton force, frictional force, weight, and normal. So this question means that it asks you to calculate W, okay, work done by component. Okay, work done by component. So you need to calculate them one by one, which means for questions A, if you look at free body diagram, now you have 4 forces. So you need to calculate work done for 4 of them. Okay, you need to calculate work done 4 times. So W, okay, by the external force, 5 Newton force, equals to, now one thing is missing in my diagram. So what is the S? Okay, S is going towards the direction that is same as my force, external force. So S is going to the right. Okay, and S is equals to 1.5 meter. Okay, so let me change the color. So W by external force is equals to, okay, let's start from equations. Fs cos theta. My F is now the external force, which is 5. And then my S is 1.5. Both of them, they are pointing towards same direction. Therefore, cos 0 degree, which then gave me 7.5 joule. Okay, so this is the first work done by external force. The second work done, okay, the second work done is which one? So second work done, let's say, is the work done by frictional force, WF. So it is equals to, now according to the question, frictional force. Okay, I'm going to substitute as the small letter F. So Fs cos theta. So frictional force is 1.6. Okay, 1.6 times 1.5. And the directions between frictional force and displacement is a 180 degree. Okay, so 180 degree is very important. You need to know how to determine a 180 degree. So it is then equals to negative 2.4 joule. Okay, next one.
Madam,
Yes?
nak tanya yang friction tu dia tak payah letak negatif ke sebab dia menghala ke arah kiri?
Tak payah. Sebab sekarang kita ambil kira dia punya angles.
Oh, okay.
Okay, so kita cuma ambil kira dia punya negative dengan positive value apabila kita anggap dia sebagai satu vektor. So work done kita sekarang dia adalah skala quantity. Okay, dia adalah skala quantity. Jadi bila kita substitute dia punya nilai sahaja. Right. Next. Okay, next. Normal force. Okay, so W normal. So W normal is equals to NS cos. Okay, now straight away I'm going to write it as a 90 degree to make it easier. And then it is equals to 0 joule. So you don't even need the values for a normal force. Okay, so you don't have to get panic. Oh, yeah, I don't have the normal force. How am I going to calculate it? No, okay, don't. And then, okay, and then next I have W weight. Okay, so W, Okay, WS cos 90 degrees. So once again, it gives you 0 joule. Okay, it gives you 0 joule. So now you have a 4 work done by 4 different components. Okay, 4 work done by 4 different components. Okay, next. Now the questions ask you to calculate total work done. How are you going to calculate total work done? So you have 2 methods, and again, I'm going to show you both of them. Okay, first method, B, W total straight away equals to WF plus WF plus WN plus WW. Okay, which is then equals to 7.5 plus negative 2.4 plus 0 plus 0, which is then equals to 5.1 joule. So this is method number 1. All right, this is method number 1. Method number 2, okay, W total equals to F net S cos theta. So this net force need to be the net force that is lying on the same component as our displacement. So go back to diagram. Our displacement is lying on the X component. Therefore, the force that we want to calculate, okay, is just the force that is lying on the X component. Okay, we want the force on the X component. So if you think F net is a bit confusing, okay, then that is fine. You can just say summations Fx also can. Okay, also can. So which is then equals to, okay, but F net is in terms in general, okay, because sometimes we might have a force that is not lying on the X component. So that would be better if you use F net. Okay, dia lebih bagus sebenarnya kalau kamu guna F net. So I have 2 forces lying on the X component. So I'm going to use F minus F. Okay, and then S cos theta. So my F is 7.5 minus 2.4. Okay, minus 2.4 times with the S. Now I have a S which is equals to 1.5. And then cos, now if you look at the vector, capital letter F minus small letter f, so it gives you a positive value, which means the net force is going to the right hand side. Okay, kita punya F net adalah ke kanan. Sebab apa? Sebab F external lebih besar daripada frictional force. So arah net force akan ikut arah yang lebih besar. Therefore, it's cos 0 degree. So eventually, you are going to get 5.1 joule as well. Okay, 5.1 joule as well. So remember, if you want to use this method, you have to be careful. All right, so this one, I would prefer to write it as F net, because sometimes you might not get the F that has the same components, that is pointing towards the same direction as the S. Okay, this question, you can use summations Fx just because the Y component, they cancel out with each other, so you have the force only on the X component. All right, so this is the second method. So, okay, as usual, I give you 2 minutes to write it down. You can write down all method, okay, but make sure you know which one you want to use, which one is easier for you to use. So 2 minutes for you to write it down. So, I rasa Anda boleh tulis juga equations ini. So, dot product A dot B is actually equals to modulus A modulus B cos theta. Okay, modulus means magnitude. That's why for frictional force, we don't include the negative sign. Okay, so this one, okay, modulus A means magnitudes of A. So modulus B, magnitude of B. Okay, so you take the magnitude only. That's why your frictional force is positive. Okay. Questions 2. Okay, questions 2, as usual, you need a free body diagram, right? You need a free body diagram. So let's see, how are we going to solve it? So an object of mass 1.5 kg is slide downwards on a smooth. So the term smooth, it tells you no friction, okay, no friction. So on a smooth inclined plane AC, and then the length, okay, AC, the length of AC is 25 meter. Determines the work done. Okay, now if you look at the question, it asks you to determine the work done by gravitational force. So in order to displace the object. So how are we going to calculate the questions? It's very simple. So okay, now to make it easier, I'm just going to sketch the diagram in the sketch the force in the diagram. So I have a W going down. Okay, so this is W, and this is the only force that I have for the gravitational force. So of course you still have a normal force, but normal force now is not important. Okay, the force that we're going to look at is just gravitational force, because that is what the questions want. Question just want work done by gravitational force. Okay, now my object is displaced, it's going down. So I have S going down, and S is equals to 25 meter. Okay, it displaced by 25 meter. So W by G is equals to W S cos theta. So what is the angles between W and S then? So if you recall, okay, if we have an x-axis and a y-axis here, angles given 20 degree is always the angle beside y component, right? Which means the angles between S and W is a 70 degree. Okay, you want the angles beside x component, because that is where your displacement go. Okay, that is the direction of the displacement. So it is equals to mgs cos 70 degree. Okay, which is then equals to m. Now m is 1.5 kg, and then g is 9.81, and then my s is the 25 cos 70 degree, which is then equals to 125.8 joule. Okay, so this is a method where I use total weight. So if you want to resolve weight before you calculate it, also can. It is up to you. Then it will become the method in green color. Okay, you can also use the method in green color. It is accepted in the exam. Okay, but now I'm just going to show you this one, okay, to make it easier for you. So straight away, you use W equals to mg. You don't have to resolve it. Okay, if you want to resolve it, then you resolve it, and cos will become cos 0 degree. Okay, the second method. Okay, let me show you also. So Wx, okay, sine cos theta. So Wx, if you resolve it, your x is going to work the same direction as your displacement. Then it is equals to mg cos 70 degree times with s, and then cos 0 degree. So eventually you are going to get 125.8 joule. All right, so this is the second method. Okay, this is the second method where you resolve weight first, so that weight is pointing towards the same direction as the displacement, or so that the weight is lying on the same component as your displacement. Okay, so dua kaedah. Dua kaedah seperti biasa terpulang pada anda. Which one you want to use? Okay, in my class, I won't force you to follow just one method. Okay, you choose it by yourself. Which one is easier for you? Okay, so next questions is very similar to questions 1. All right, so I give you 3 minutes to solve it. Okay, soalan seterusnya dia agak sama. Okay, kita kata lebih kurang sama dengan soalan 1. You need to identify the directions of all forces first. I would encourage you to draw a free body diagram. Okay, and then from there you determine the force by each component. Okay, and then after you determine the force by each component, you then calculate the total work done. All right, so 3 minutes for you to solve it. You just need a free body diagram, and then you calculate the force by component, and then you just add them up to calculate total work done. So it looks complicated, but the idea is exactly same as question 1. All right, so 3 minutes for you to try it. Dia tak susah. Okay, dia tak susah. Okay, kalau ada soalan boleh tanya ya, sebab setakat ini masih soalan yang senang. Okay, so let's see how are we going to solve these questions. Now, a box of mass 20 kg move up a rough plane. Okay, so now you have a rough plane. That's why you have a frictional force in the diagram, which is inclined to the horizontal at a 25 degree, and it is pulled by a horizontal force. Okay, so these questions sometimes is a bit tricky. It says horizontal force means it's truly horizontal. Okay, it is not parallel to the plane. So this is a part where students often got it wrong in the exam. Horizontal force, it truly means horizontal. Okay, it doesn't mean it is parallel to the surface. So make sure you understand how to sketch the free body diagram. Of a magnitude 250 Newton, the coefficient of kinetic frictions between the box and the plane is a 0.3. If the box travels 3 meters along the plane, then you determine the work done by each force. So now let's see what is the free body diagram. So I have a W going down, and then F going to the right hand side, and then a normal force going to work this direction, and frictions going to here. Okay, frictions going to here. Okay, it's a bit too long. Okay. And then my S is going to here. Okay, it's going to here. So now let me insert the angles. Okay, let me put the angle. So this is my y-axis. This is my x-axis. Okay, so x-axis is parallel to the S. So angles given 25 degree, okay, the inclined plane. So 25 degree is beside your W. Okay, 25 degrees beside W. And then angles, what else do I have? This is a 90 degree. Okay, so if W and the external force is from 90 degree, okay, it means the 25 degree is here. Okay, it's located beside x-axis for the force. Okay, for the F, external force, the horizontal force. Why? Okay, how do I know? That is because here is 90 degree. Okay, here 90 degree, and then this part is a 65 degree, right? And then from Y component until horizontal force is also 65 degree. Therefore, my Fx, okay, the F between F, the external force, the horizontal force, and the X component is 25 degree. So you need to know all these angles before you solve the questions. Okay, before you solve the questions. Okay, now I'm ready. Okay, I got all the angles, and then I got all 4 forces in my free body diagram. So let us begin with force. Okay, we follow the sequence in the questions. So WF, W horizontal force. So horizontal force times displacement cos theta. Horizontal force given is 250. Okay, 250, and then it moved up by 3.8 meter. Okay, 3.8 meter, and then cos, now you look at the diagram, angles between X component and horizontal force is 25 degree, therefore cos 25. Okay, so angles between this one and your X component, so it's 25 degree, right? So therefore the answer is equals to 861 joule. Okay, 861 joule. So you just press the calculator. Make sure your calculator is in degree mode. Okay, it's in degree mode. All right, the second one. Okay, second one is gravitational force. So W equals to WS cos theta. So you have to be careful, yeah. The first W here, it represents work done. Okay, it represents work done. The second W here is the weight. So make sure you use the right symbol. Okay, you use the right symbol. So W equals to, okay, W S cos theta. So do I have the weight? No, but what do I have? I have the mass, which is equals to 20 kg. So mg 29.81. So this is the weight. right? This represents weight because W equals to mg, and then times with S 3.8. Now, what is the angles between W and S now? Look at the diagram. My S is lying along the X component, okay? It's going up. My W is going down. So the angles between them is 90 degree plus 25 degree, which is equals to 115 degree. Okay, 115 degree. So cos 115 degree, which then give you negative 315 joule. Okay, negative 315 joule. And then followed by reaction force, which is our normal force. So Wn equals to, and S straight away cos 90 degrees. So you don't even have to calculate. It is equals to 0 joule. Okay, it is equals to 0 joules. And then the last one is the frictional force. So Wf equals to Fs cos, okay, so frictional force and S, they are pointing towards opposite direction. So 180 degree. Okay, 180 degree. But now, okay, the question is, I don't have frictional force. Okay, but what I do know is frictional force is mu n. Okay, mu n as cos 180 degree. So next step, I need to calculate n. Okay, I need to calculate n. So you need to do an additional step to calculate the normal force first. So how are we going to calculate normal force? Let's go back to free body diagram. Free body diagram, this is my x component and this is my y component. So my normal force is lying along the y component. Okay, so I'm going to use summations Fy. Now, my object is moving along the x component, which means for y component, we apply Newton's first law. Okay, so Newton's first law, summations Fy is equal to 0. So along y component, I have normal force, which is going upwards, minus what? Now, if you look at the diagram, I have W and the horizontal force. Both of them, they are not lying on the x component nor y component. Okay, they are not lying on the x component or y component, which means you need to resolve. Okay, you need to resolve W and F into y component so that you can use it to calculate normal force. So now let's see. I have n minus, okay, W, which is mg cos 25 degree minus F cos 65 degree. It is equals to 0. Okay, so from here you calculate the normal force. You are going to get a value which is equals to 283.5 Newton. Okay, you then use it in a work done for frictional force. So now you need this additional step. Okay, you need this additional step to calculate work done by frictional force because we don't have n. So mu given, okay, mu is given, which is equals to 0.3. So 0.3, and then times with normal force, which is 283.5, times with displacement 3.8, and now the angles between them is cos 180 degree. So you're going to get negative 323.2 joule. Okay, so that is how you solve the first questions. Questions A. Okay, questions A. So questions B, I will leave it to you. Basically, you just add them up. Okay, so you add up this value. Okay, this first value. This is the second value. And then this is the third value. And then this is the fourth value. You add them up, you're going to get the answer for questions B. All right. So I give you, now it's 2:51. I give you 4 minutes. We will continue again at 2:55. Okay, 2:55. So 4 minutes for you to write it down, especially the things in a green color. It's very, very important. So if there's anything that you don't understand, make sure to ask. Okay, so far, any questions? So far, any questions? I think we are done with the calculations part. Okay, the calculations, the basic calculations, the fundamental calculations. All right. So if you have any questions, you better ask now before we proceed to a 5.2, because 5.2 situations get a slightly more complicated. Okay, so if you can't even understand these first three questions, then it will be hard for you to follow the things that we're going to learn in 5.2 and 5.3. Okay, so kalau ada soalan, pastikan tanya sekarang. Ada. Oh, bagusnya kelas ini sentiasa tak ada soalan. Okay, next. So next, the components fx of a variable force which is parallel to the x-axis, okay, varies with displacement x in the ways as shown in figure. So usually when it comes to the graph questions, they will give you one statement to explain what is going on in the graph. Okay, so now you want to determine the work done on an object by the force component if it is moving from from 0 until x equals to 20. Okay, so basically the whole graph. So how are you going to answer these questions? If you remember what I told you in chapter 3, you need to state which part of the graph represents the informations that we want. So for example, now you want to calculate work done. So work done, the first thing that you need to mention is not the value, but you need to mention work done is equals to area under fx graph. Okay, why? Because this statement itself, it gives you 1 mark in your exam. Okay, it represents concept. It means you understand. Okay, you understand what is the meanings of this graph. Why can you get the information that you want from the graph? So this statement itself is a must in your exam when it comes to graph questions. All right. So work done equals to area under fx graph. So now you have a triangle. So triangle is the base times height divided by 2. So 1/2 times 20 times the height, which is 10. All right. Which then give you 100 joule. So be careful. All of them, you need to make sure they are in SI unit. Okay, so you check the unit of the axis. Okay, so you have a Newton and then you have a meter. So they are in terms of SI unit. So done. That is the first question. It's very simple. Second questions. Okay, second questions. How are we going to calculate it? So let's see. The force on a body varies with displacement. Okay, from a point X as shown in the graph. Calculate work done by the body if it is displaced from 0 until 0.4. So first part is the first triangles, and then second part is the second triangle. Okay, so now what are you going to do? You're going to calculate them one by one. So first one, again, you need to mention work done is equals to area under fs graph. Okay, because now you're given symbol in terms of s, so you write it as area under fs graph. Then it is equals to 1/2, okay, 0.4 times 4, which then give you 0.8 joule. Okay, that is for displacement from 0 until 0.4 meter. Okay, now second questions, B. Okay, so B again, work done now. Because they're in the same questions, therefore you don't have to repeat the statement again because 1 mark is already given in questions A. So straight away you can proceed to calculate work done. Okay, so work done is equals to 1/2. So the first things that you need to calculate is this length. Okay, the S. So S is a 0.8 minus 0.4. Okay, and then times with the force. Now force is a negative value. Okay, so in this case, because it's coming from graph, you need to include its negative value. All right, so when it comes to graph, you need to include negative value for force. But if you just calculate the dot product, okay, which is your Fs cos theta, then in that case, you use the magnitude only, the value without negative sign. All right, so which then equals to negative 0.4 joule. Okay, negative 0.4 joule. Right? So the answer is wrong. It should be negative 0.4 joule. So which means this is actually energy loss. Okay, a negative value is your energy loss. So now if these questions, now if I want to add one more questions, it's not one more, sorry, I need to add them up, okay? Because why? Because if you look at the questions, it asks you to calculate from 0, okay? Not just from a 0.4 until 0.8. It asks you to calculate from 0. Then it means, okay, it means it wants you to calculate the total work done. Okay, so total work done, W total is equals to 0.8 joule plus negative 0.4 joule. Okay, so the answer is correct. My bad. Okay, my bad. So the answer is 0.4 because now you calculate total work done. So you use 0.8 minus 0.4, which then give you 0.4 joule. Right? So you have 3 different work done. First one is from 0 until 0.4 meter. Okay. Yeah, it's hang again. Okay, 0 to 0.4 meter, and then this one is 0.4 to 0.8 meter, and then the last one is from 0 to 0.8 meter. Okay, so basically we have 3 different work done in these questions. All right, so we are done. One more graph questions. So one more graph questions, I will give you a 1 minute to solve it. Okay, actually it's very simple. Okay, you look at the shape, you look at the questions, then you should know how to calculate it. Okay, so yeah, I give you some time to solve it. Try it by yourself. See whether you can get 18 joules or not. If you can get 18 joules, means you understand the questions already. Okay, if you cannot get, means there's something wrong in your idea, in your concept. Then we will go through the answer together. Okay, so you tried it first. Okay, boleh tak boleh, nanti kamu tanda. So this is very similar to previous question. Remember, yeah, you have a negative work done in this graph. Okay, you have a negative work done in this graph. Okay, so a horizontal force applies to a 2 kg radio control car as it moves along a straight track. The force varies with the displacements that the car shown in the figure. Calculate the work done for it to move from 0 until 7 meters. So these questions, you can split it into a few parts, or you can straight away calculate it in one equations. All right. So the most important things, again, you need to tell the examiner. Work done is equals to area under Fs graph. Okay, and now you have everything in terms of SI unit. Straight away, you can proceed to calculate the area. So area under Fs graph, okay, you can calculate them by part. Okay, you can split the trapezium and the triangles. You can split to triangle, rectangles, triangles. It's up to you. Okay, or you can combine them into one equation straight away. So for example, this is what I'm going to do now. So I put a square bracket. I want to calculate the positive area first. So positive area is a trapezium. So 1 over 2. What am I going to do now? Okay, 3 to 5, 5 to 3. So, let me see how am I going to calculate it. So I'm going to add the base first. Okay, the base is here. So which is a 6. Okay, which is a 6. And then plus the length here. This one is 2 because it's 5 minus 3. So 2 times the height of the trapezium, which is 5. So this is the area, the positive area. Okay, I calculate the positive area first by using the first square bracket. So minus or plus. I'm going to use plus. Okay, because total area. Aha, so this is the tricky part. Okay, if you combine them into one equation, this is a tricky part. You need to add them up. Okay, you need to add them up. But then when you calculate the area for these triangles, 1 over 2 times the base, which is 1, times the force, which is negative 4. And that is where you obtain the minus sign in the calculation. Okay, so remember when you calculate the area, you are actually calculating the total area. So you use a plus sign in equation. But when you substitute F as a negative value. All right. So therefore, you're going to get 18 joule. Okay, so if you think this is hard to understand, you can just do like, okay, what I did in the previous question. So you calculate the positive area first, and then you calculate the negative area, and then you add them up. Oops. Okay, you add them up like this. So 0.8 plus negative 0.4. Okay, so the idea is the same. Okay, the idea is the same, just that now because I combine everything into one equations, I do it in one shot, so it might look a bit complicated. Okay, so actually it's equals to 20 plus negative 2. Okay, 20 plus negative 2. So it is the same. All right, so we are done with 5.1. Yes, any questions?
Madam?
Yeah?
Is it okay if you repeat question 3 again? I really don't understand with the solutions that you have written. I tried to
Come
understand.
on lah. This one, the first part, is just the
No,
area.
Question 3.
Oh, you don't understand the questions.
Yeah, question 3, yeah.
Oh, I thought you say you don't understand the solution. Okay, now, question 3. A force is applied to a 2 kg radio control car. So
No,
now...
madam. The earlier question you did, question 3.
Questions. Come on, we are at the question 6. You asked me to repeat questions 3.
Try to understand using by the solution, I really don't understand. Sorry.
Questions 3. Which part of it you don't understand? Come.
The N minus W, the one, the summation of F equals to 0, Fy equals 0, that part.
Well, it's just like what you have been doing in chapter 4, right? In chapter 4, you want to calculate the force. So what are you doing? You solve them according to the component. So now you have X component and you have a Y component. Okay, X component and Y component in the diagram. So your normal force is lying on the Y component. There's no motions along Y component. Therefore, of course, you're going to apply Newton's first law. So when you apply Newton's first law, you try to identify how many forces do you have along this vertical component.
Okay, I understand the part that mg cos 25, yes, but I don't understand the part F cos 65.
Well, because you have a force, the external force, which is lying in between X and Y component, you need to resolve it.
Oh, so you have to take both forces include in the solution.
Of course, because both of them, they are part of your Y component.
Oh, okay.
Okay,
So actually we are finding the Y component on the downside lah, because the upside is N. Oh, okay.
Okay, so it doesn't matter how many forces do you have in the diagram. If they are not lying on the X or Y component, then you have to resolve all of them. You cannot just simply resolve one of them. So in these questions, what are we doing? We resolve Wx, and then we also resolve, Wy, and then we also resolve F to becomes Fy. Okay, just that their X component, Wx is on the negative side, but Fx is going to the positive side. So you have to resolve every single forces that is not lying on the component, on the X or Y component.
Okay, clear.
All right.
Thank you so much, madam.
Okay, good. So now is questions. Okay, so we are done with our 6 questions. Okay, now let's look at 5.2. 5.2. Okay, so before I start 5.2, now any other questions? Oh, yang lain jangan segan. So any other questions? 5.2. No, if no, then okay, let us move on to 5.2. So done, yeah, 5.1. So energy and conservations of energy. So let us do a quick recall. So in lecture, we have seen 3 types of energy. The first one is our kinetic energy, which is equals to 1/2 mv squared. The second types of energy is a gravitational potential energy, which is mgh. And the third types of energy is our elastic potential energy. Okay, so elastic potential energy, we have the equations 1/2 kx. Okay, 1/2 kx squared. So the equation, it looks very similar to the kinetic energy one, just that now you are using the difference variable. Okay, so and a k, okay, k is your spring constant. Okay, because most of the times we are looking at what happens in the spring. What is the energy that is being stored in the spring? Okay, so these are the energies that we have. So these 3 energy, okay, they are always conserved. Okay, so they are all being called as a mechanical energy. So in an ideal situations, they are always conserved. Okay, so in an ideal or in a closed system, okay, in closed system, total initial mechanical energy is always equals to the total final mechanical energy. So it is up to you how you want to use them, but the total of them, okay, it doesn't matter how many types of energy you have in the system, but the total before and the total after, they must be the same. So in which it means K initial plus UG initial plus US initial is always equals to the total K final plus UG final plus US final. Okay, in a closed system. Now, sometimes it experiences energy loss. Okay, so if it experiences energy loss, then what are you going to do? So if there's an energy loss, okay, if there's energy loss, then it will become summations E initial plus E loss. Okay, energy loss equals to summations E final. So energy loss, usually it refers to the work done by frictional force. Okay, so when it comes to work done by frictional force, okay, it is always a negative value. So that is the things that we have learned in lecture. Okay, so usually it's equals to, okay, total initial plus W friction equals to summations EF. And this frictions, okay, is always Fs cos 180 degree, which means it is a negative value. Okay, it is a negative value. So this is the things that we have learned in lecture. Alright, kita sudah tengok dalam lecture. So Anda kena tahu when to use which equations and how are we going to form equation based on the principle of conservation of energy. Right. So the questions in this part in 5.2, there's no definite equation. It depends on the information given. It depends on how we form it. Some equations, they might have all K, UG, US. Some of them, they just have K and UG. Some of them, they might just have K and US. All right. So it depends on how we form the equations. So let us begin with the first question. So you have an object which is 5 meters above the ground, is released from rest, and then determine the speed of the object when it is located at 3 meters above the ground. So this is our diagram. We have a ground. So usually we take ground as h equals to 0. Okay, usually we take ground as h equals to 0. And then now you drop an object from a height that is 5 meters from the ground. Okay, so this is our initial state. Okay, our initial state. So at this initial state, what is the information that we have? It tells us our object is at rest. So what does it mean by at rest? At rest, it means velocity equals to 0. If velocity equals to 0, then our k is equals to 0. Aha. So you see from the term at rest itself, it gives us that much information. All right. And then what else? So it asks you to determine the speed when the object is 3 meters above the ground. So now it hasn't reached the ground yet. So it is 3 meters above the ground. So this is our final state. So at final state, okay, what do we know? We know h is equals to 3 meters, which means our potential energy is not 0. Okay, so just now, initial state, we also have potential energy because h is equals to 5, therefore u is not 0. Okay, and then at the final state, what else do we have? Well, it asks us to calculate speed. So v is a non-zero value, so which means our k is also a non-zero value. All right, and you look at the system, okay, you look at the diagram. There's no spring involved in our system. Therefore, we don't have US. What we have is just UG. Okay, because UG is being affected by the positions of the object. And now our object, it changes its position. Therefore, UG is a non-zero value. Okay, and K is being caused by motion. Now my object is moving with a velocity. Therefore, K is a non-zero value at its final state. Okay, so now I'm going to solve these questions by using the principle of conservation of energy. So according to principle of conservation of energy, summations E initial is equal to summations E final. Okay, so if you look at the questions, okay, look at the diagrams, the energy involved is kinetic energy and potential energy. So I'm going to write it down in a general form first. So K initial plus UG initial equals to K final plus UG final. Okay, I can ignore US because there's no spring in my diagram in the questions. Okay, so according to my diagram, K initial is 0. So 0 plus, now I'm going to expand it. So initial potential energy is a non-zero value. So I'm going to write it as mgh initial. M and G don't need subscript because they are constant value. As long as you're still using the same object, then the mass is fixed. Okay, and G is a gravitational acceleration. So it's always equals to 9.81. Then equals to final K. Well, final K, now you want to find the velocity. Of course, it's a non-zero value. So 1 over 2 mv squared plus now mg h with a subscript f. Okay, the final h. So initial h we have 5. Final h is equal to 3. Okay, so now you have all the equations. What are you going to do next? Okay, you sub the value into the equation. But then, one questions. I don't have mass, right? I'm not given some mass of an object. But if you observe, okay, if you look at these equations, what can be observed is, now every single term comes with m. So it means that you can actually cancel it out without calculating it. Okay, potong terus because semua dia ada m dan m punya nilai semua sama. Because now you're looking at the same object. Okay, so you cancel out all m, then now you can substitute the value. So 9.81. Again, now, quite often students like to ask me, do I have to substitute negative in G? No. G is a positive value, 9.81. A is a negative G. Therefore, it's negative 9.81. Don't get confused between A and G. Okay, don't get confused between A and G. So G is just 9.81. H initial H is 5 equals to 1 over 2. Now V is the values that we want to calculate. So leave it as a variable, as unknown. plus 9.81 final h is 3. Rearrange the equations, you are going to obtain V equals to 6.26 ms negative 1. So done. Okay, so this question is very simple. The only question that you might have is, G, do you have to substitute as a negative value? The answer is no. All right, the answer is no. So now I give you some times to write it down, okay, including the notes in the blue color. Oops. Okay, the notes in the blue color is actually the revision for you. So I give you 5 minutes to write everything down. Okay, benda-benda dalam warna biru ini kamu boleh tulis sebagai revision, and then baru sambung dengan solutions kita. Okay, baru sambung dengan solutions kita. So exercise 3, solutions pertama. Okay, lukis diagram. Okay, oh, it is always a good idea to sketch diagram, yeah? It doesn't matter in which chapter. Diagram is your best friend. If you know how to sketch the diagram, means you understand the question. That's why in my class, I always encourage my students to sketch diagram, even though it's just a very, very simple question. Okay, so 5 minutes for you. If you got any questions, you can ask. Okay, so we'll continue with another 2 to 3 questions. Then that will be the ends for today. Okay, I will go through the easier question first. The harder questions, I'll keep it for tomorrow. So tonight you go through the revisions. Make sure you understand the things that we go through today before we proceed to a much harder questions tomorrow. Right. Now, questions number 2. Questions number 2, actually, it just want to test, see whether your concept is okay or not. Okay. So it refers to the figure above. Determines the speed of the object when it reaches point A and point B. So you look at this diagram. Now you have 3 different points. This is your initial. Okay, and now you have 2 different final position. So basically what happened in this diagram is that the total energy, mechanical energy at initial position is equal to the total energy at point A, and at the same time it is equal to the total energy at point B. Why? Because energy is conserved. Okay, energy is conserved. So this is the things that we need to know. All right. So figure above shows, refers to the figure above, determines the speed of the object when it reaches point A. So we often take the ground as h equals to 0. Okay, this ground is a h equals to 0. So at point A, your h is equal to 0, means that at point A there is no potential energy. Okay, so questions 8. So you look at these questions, obviously the energy that involved once again is K and UG only. Okay, therefore summations E initial is equal to summations E, now let's say at point A. Okay, at point A. So what am I going to do now? Okay, I'm going to expand the equations. So K initial plus UG initial is equals to K at point A plus UG at point A. Then I'm going to expand it. 1 over 2m. Now, initial K, usually we use U as the velocity, all right? So 1 over 2m U square plus mgh initial equals to 1 over 2m V square plus mgh at point A. Okay, so again, when it comes to these questions, the things that you can throw away in the equation is m, because all of them, they refers to the same object. They have the same m. You are looking at the same object. And then another things that we can remove from our equation is the u for point A. Why? Because at point A, your HA is equal to 0. So this whole thing, you can just remove it. So the remaining part in our question is, okay, 1 over 2 initial velocity given is 10. So 10 square plus 9.81 with the initial height is 5 meter equals to 1 over 2 V square. So rearrange the equations. V is equals to 14.07 ms negative 1. Right? So now you just repeat the same thing for object B. But then if you look at the diagram, now my object B, okay, is not at its highest position, and it's also not at a h equals to 0. So what does it mean? It means I have a non-zero K. Oops. Okay, I have a non-zero K and I have a non-zero U at point B. Okay, now let's begin. Summations E initial equals to summations EB. K initial plus UG initial equals to KB plus UGB. 1 over 2 MU square plus MGH initial equals to 1 over 2 MV square plus MGHB. The things that you can remove from the equations now is just the M. Okay, it's just the M. All right, and then what are we going to do next? So we want to calculate velocity, right? We want to calculate velocity. So you sub everything into the equations. Okay, you sub all of the informations into the equations. So you have a 1 over 2. Oops, wrong color. 1 1/2 10 square plus 9.81 times 5 equals to 1/2 v square plus 9.81. Now the height given is 3. So rearrange the equations, you will obtain v equals to 11.8 ms negative 1. So this question is very similar to the previous questions. The only difference is now it gives you one more position. Okay, it gives you one more position. So what you have to know is that at these 3 positions, their total energy, they are all equal because of energy is conserved. Okay, energy is conserved. Now, if you want to use summations EA, okay, for example, students, they might ask me, can I use summations EA equals to summations EB to solve these questions? Of course you can, nothing's wrong. Okay, nothing's wrong. You can use summations EA equals to summations EB to solve it. Okay, since now you have the velocity at point A already. All right, so nothing's wrong. It is up to you how you want to solve it. As long as you know energy is conserved at every position, then that's it. Okay, so I give you 2 minutes to write it down. This is a very simple question, so I'm not going to waste too much time on it. Okay, 2 minutes for you to write it down, then we proceed to the next questions. Okay, setakat ini semua masih okay kan? Soalan ini dia masih dalam jenis closed system, okay? Dia tak ada lagi friction lagi. So it's still considered a very basic and easy questions. Alright, next. Aha, now there is something new in our diagram, right? Ada benda baru sudah. So what is it? Now we have a spring. Okay, we have a spring. Okay, now an object of mass 2 kg is placed 2 meters directly above the top, okay, of the top end of a vertical spring, as shown in figure above. The spring has a spring constant of 500 Newton per meter, and then determines the maximum compressions undergone by the spring when the object falls on it. Okay, so it asks you to calculate maximum compressions. How are we going to calculate the maximum compressions? That is the questions. Okay, that is the questions. So, all right, what am I going to do now? Let's see, how many types of forces do I have? Okay, now you have an object that is being placed at a certain height. So you have a gravitational potential energy. And then this object, when you drops it, okay, it's moving, right? It's moving. But now, wait, yeah, let me see. So it's moving, you drop it, it's moving with a velocity, and then it reaches a spring, okay? It undergoes a maximum compressions. So it undergoes a maximum compressions means that it presses the maximum, it presses your springs until it's a maximum distance. Okay, so what am I going to do now? I want to sketch one more diagram. Okay, I want to sketch one more diagram. This is a spring. Now this spring has already undergone a compression. So this is the object. Okay, this is the object. So what am I going to do right now to make it easier for me to calculate? Okay, to make it easier for me to calculate, what am I going to do? Yeah, let me see first. I'm going to take y as a 0. Ya, saya fikir saya nak ambil mana sebagai kosong. take, if I'm going to take, okay, I'm going to take the compressions as 0. Okay, I'm going to take here as 0. So this is H equals to 0. All right. So in which it means when the object undergoes compressions, then our initial H will got a slight changes. Okay, we will have a slight difference. So our H initial, H initial is equals to 2 plus the compression, which is X. Okay, our H final is equals to 0. So that is what I'm going to do now. Okay, that's what I'm going to do now. So the compressions here, okay, so this one, initial positions, my compression for spring is X. Okay, compressions for spring is X. All right, let's see. How am I going to solve it? So 2 kg object. So let's begin with summations E initial equals to summations E final. Okay, and then wait a moment, yeah, I need to get something. Okay, you take 1 minute to do it first. I need to take something. Okay, I need to take a note. Okay. Wait, yeah, let me see. How am I going to change? Okay, I'm going to modify the information a little bit. Okay, I'm going to modify it a little bit. Because for compressions, if you want to take a positive X, you need to take the initial positions as 0. Okay, so I nak modify dia sikit. I'm going to take the original positions of the plate as 0. Okay. Because I want to show you one more thing. In potential energy, we can actually have a negative value. Okay, so we take here as H equals to 0. So your initial H is 2 meter. Okay, so this 2 meter is your initial H. Now, how about your final H? So in this case, okay, the compression for spring is X. Okay, but when it comes to H, your H final is actually negative X. Why? Because you are taking here as a 0, now it's located below 0. Okay, saya tukar soalan sikit sebab saya nak introduce negative X kepada anda. So you can actually have a negative H. All right, if you take here as a 0 position. So in the questions, actually it's up to you. You want to take where as H equals to 0. Okay, now I take here as H equals to 0 so that I can introduce a negative value to you. All right, H equals to 0, and what happened is now I'm going to expand the equations. K initial plus UG initial plus US initial equals to K final plus UG final, okay, and then plus US final. Okay, now I include all of them in my calculations. The reasons why I include all of them in my calculation, that is because now I have a kinetic energy, I have potential energy, and I also have a spring in the questions. Okay, I also have a spring in the questions. Okay, next, what am I going to do? Okay, I want to see. Okay, I want to see which one can I remove first. Aha. Okay, so before I expand the equations, the variables that I can remove. Now, even though I know now my object is moving, right? My object is moving from maximum height until the spring stop. What is the information that you can get from these two terms? Now, you drop an object, okay? You drop an object. When you drop an object, its initial velocity is equal to 0, which means at initial state, your K initial is actually equal to 0. And then at maximum compression, okay, what happens at maximum compression? At maximum compressions, the spring, the object will stop for a moment. Therefore, we can say V is also equals to 0. Therefore, our K final is also equals to 0. So even though we know that kinetic energy, it exists in the motion, okay, but now because we are taking the highest point and the maximum compression point where velocity is equals to 0, therefore we can remove K from our equation. Okay, so I repeat ya, saya ulang sekali lagi. Kenapa saya boleh buang K saya? Sebab saya ambil K initial, okay, adalah when I drop the object. So before you drop the object, initial velocity is equal to 0. So K initial, of course, is equal to 0. Okay, and the final positions that I'm taking right now, okay, final positions yang saya ambil sekarang adalah maximum compressions of the spring. So when will we have maximum compression? Okay, when we have maximum compressions, it means you cannot compress the spring anymore. And therefore, our object stop at that moment. Okay, in which it means our final velocity is also equal to 0. Therefore, K final is equal to 0. Okay, so maximum compressions, kita pun dah tak ada K dah. Sebab dia dah compress sampai tak boleh compress. Sudah. Objek kamu berhenti sudah. Okay, so K initial dengan K final, therefore kita boleh anggap sebagai kosong. But if it hasn't reached maximum compression, then K is a non-zero value. Okay, so boleh beza tak? Sekarang dia main dengan ayat dia. Okay, dia main dengan ayat, dia main dengan posisi objek. Alright, so K initial and K final in this situation is equal to 0. Alright, now there's one more thing which is equal to 0, which is initial spring. Initial potential energy, elastic potential energy. Why? Because initially, before you drop the object, it hasn't touched the spring yet. So US initial is also equal to 0. Because initial state, which is here, it hasn't in contact with the spring. So no elastic potential energy yet. So elastic potential energy only exists in the final state when the spring is being compressed. Okay, so spring being compressed, US is not equal to 0. Right? So US is a non-zero value. Yes? Siapa nak tanya soalan? Ada? Okay, now, how about gravitational potential energy? Gravitational potential energy at initial position, of course, no argument because it's above the plate. At final, it's also not equal to 0. Why? Because it's now below H equals to 0. So it has a value, just that now the value is a negative value. Okay, so we have a negative value here. So kita ada nilai negative. So HF is also a non-zero value, but it is a negative value. Why? Because now it's below H equals to 0. Since we choose H equals to 0, is located at the height of the plate before the spring being compressed. So after you compress it, H is a negative value. All right. So if I'm not mistaken, in the past year questions, you have a questions that involve a well. Okay, so the height of the well is a negative H as well because we take the well, the ground as H equals to 0. All right, so this is one of the past year question. That's why I want to introduce negative H to you. Okay. So nanti kamu buat soalan pasir, kamu akan nampak satu soalan yang berkaitan dengan well. Well itu panggil apa ya? Saya dah lupa dah dalam bahasa Melayu. Okay, so nanti kamu akan tahu bila nak guna negative H. So now I'm going to expand the equation. So I have mgh initial equals to mgh final plus 1/2 kx squared. Okay. So now because I compress it, so I have a value x, okay, is an unknown. So H is equal to, H final is equal to the compressions. Therefore, my H final, okay, is equals to x, but because it's below H equals to 0, so negative x. So now we can solve the questions. Okay, we can solve the questions. So m is 2 kg. So now this m, you cannot remove it from the equation. Why? Because your elastic potential energy doesn't have m. So you cannot just cancel it out. So you need to substitute the value. So 2 times 9.81 times initial height, which is 2, equals to, now I have m, which is 2, 9.81, but now the h I'm going to substitute as negative x, right? Plus 1 over 2, spring constant given 500, and then x squared. So rearrange the equations, okay, rearrange the equations, you will obtain x equals to 0.437 meter, okay? X equals to 0.437 meter. So that is the compression, that is the maximum compression. All right, so the tricky part in this question is because of the h, the final h, and it asks you, it wants you to choose where is your h equals to 0. Okay, so because I choose the plate as h equals to 0, therefore my final h is a negative x. Now, can I choose the maximum compression as h equals to 0? Yes, I can. Okay, so let's see. So if I take maximum compression, so this is my initial, okay, initial plate, and then this is what happens when after I compress it. So if I take maximum compression as h equals to 0, okay, then it simply means that my u final is equals to 0, and then my h initial, okay, h initial is 2 plus x. Okay, it's 2 plus x. So from here, you can also save the, you can also solve the questions. Okay, you can also solve the questions, and you are still going to get x equals to 0.437. Okay, so ini cara yang saya tunjuk kamu tadi. Okay, pada awalnya. Pada awal saya ambil maximum compression that h equals to 0. So in that case, I have u g final equals to 0. Okay, tetapi saya tukar menjadi yang saya tunjuk kamu dalam warna merah punya. Why? Because I want you to learn what happens if you have a h below h equals 0. Okay, dia boleh berlaku ya, dia bukan tak boleh berlaku. Okay, that's why I change it, because I want to introduce a new concept to you, a new things to you. All right, so now these questions, I give you 3 minutes to write it down. Okay, so the important thing is h equals to negative x. Okay, so 3 minutes for you to write it down. If you have any questions, then you may ask. If you want to try another method, go ahead. Okay, tak ada salah, tak ada salah. It is totally up to you. Where is h equals to 0? Okay, lepas ini kita sambung lagi satu soalan yang senang tanpa energy loss. Dan esok kita akan tengok soalan yang ada energy loss. Okay, kalau ada apa-apa yang tak faham, kena tanya ya. Sebab soalan ini dia rumit sedikit. Okay, dia rumit sedikit. Disebabkan oleh dia punya H. Okay, boleh tak setakat ini? Okay, soalan ini yang anda kena fikir sedikit sahaja. Okay, soalan-soalan lain yang kita bincang hari ini saya rasa masih dalam tahap yang kamu boleh faham. Okay, dia tak complicated sangat. Cuma soalan ini dia complicated sedikit. Okay, so next, okay, last questions for today class. So I will upload this video tonight. Okay, if you want to go through it again, then you can go through it. All right, now last questions. Okay, last questions. A child with a mass of m rides on an irregular curved slide of a height h equals to 2 meters, as shown in the figure. It starts from rest at the top. Okay, so at initial position, the informations that we have once again, h equals to 2 meters, which tells us ug initial is a non-zero value. But then our initial velocity is equal to 0. Therefore, k initial is equal to 0. So determine the speed at the bottom, assuming no frictions. Okay, assuming no friction, force is present. So at the bottom, okay, at the final state, what happened is now our h is equal to 0. Okay, usually, like I told you, we take the ground as 0. So h equals to 0. Therefore, our UGF is equal to 0. Okay, but then our K final is a non-zero value now because now you want to determine the velocity. Now, does it matter what is the shape of this ride? It doesn't matter. Okay, because now you're looking at the energy. What you want is just the initial positions and the final position. The path is not that important. Okay, the path is not that important. So how are we going to calculate it then? So let's see. So we want to substitute all equations. So we substitute summations E initial equals to summations E final. But yeah, I think the questions got something wrong. You need to change the questions a little bit. Why? Because this assumption, okay, this assumption is for questions B. Okay, it's not for the whole questions. Otherwise, what is the point of determining the final speed if it's given? Okay, so questions dia ada sedikit salah. You move the assume to questions B. Okay, that is for questions B, not for the whole questions. So questions A, we don't have a V final yet. V final is unknown. So summations E initials equals to summations E final. Okay, so according to our diagram just now, okay, we know that K initial is equal to 0. Okay, so if you want to, okay, to be safe, we write K initial first plus UG initial equals to K final plus UG final. Then we cancel the things that is equal to 0. So initially, K initial is 0, U final is 0. Okay, oops. Then we can substitute the equations. So mgh initial equals to 1 over 2 mv squared. So m and m, you can cancel it out. Again, g is 9.81. And then given h is equals to, what is the h here? Let me check. It's 2 meters. Okay, 2 meters equals to 1 over 2 v squared. So v is equals to 6.26 ms negative 1. Okay, 6.26 ms negative 1. So that is for questions A. Okay, questions A, still no energy loss. Okay, still no energy loss. Okay, now let's look at questions B. Questions B, now it asks you to calculate friction force. Okay, friction of the force, if the force of frictions, how much energy loss? Okay, it asks you to calculate energy loss. So energy loss, how are we going to do the equations then? Okay, remember, summations E initial plus E loss, okay, equals to summations E final. That is our equations. Okay, that is our equation. So what are we going to do now? We expand the equation. So K initial plus UG initial plus energy loss equals to K final plus UG final. All right. So again, the thing that is equals to 0 is our K initial and UG final. So the remaining terms that we have is mgh initial plus energy loss equals to 1/2 mv squared. But now this v, remember this v, you cannot take v from questions A. Okay, v from questions A, this is the final velocity if there's no frictional force. Okay, if there's no frictional force, means there's no energy loss. Now the v that we're going to use here, okay, is the final velocity. Okay, final velocity calculated with frictional force. Okay, final velocity after you've gone through the frictional force. Therefore, this v is no longer equals to 6.26. Of course, it will become slower. Why? Because now it experiences energy loss, the velocity decrease. Okay, it becomes slower because of the energy loss. So this v is now equals to 3. Okay, that's why I asked you to do some corrections on the question, because now this v is the v for questions B. All right, it's the B for questions B, not V for questions A. Okay, so now that I have all of the informations that I needed, let us continue. Okay, let us finish these questions. So 9, I have the mass 2 kg. Now I cannot cancel the m anymore, okay, because energy loss doesn't come with m. So I need to substitute the value, which is 2 kg. Okay, questions gave us 2 kg. So times 2.
Madam.
Huh?
2 kg ke 20?
Oh, 20, sorry, my bad. Thank you. So 20 kg times 9.81 and then times the height 2. Okay, height is 2. So plus energy loss equals to 1/2 times 20. Now the v, you have to take 3. Okay, 3 squared. So rearrange the equations. You will obtain E loss is a negative value, which is negative 302 joule. Okay, if you rearrange, if you calculate everything correctly. So energy loss is equals to negative 302. So energy loss is always a negative value, right? Energy loss is always a negative value. So done. That marks the end of today's class, which shows you the basic idea of the differences between with and without energy loss. Okay, without energy loss, your final velocity is higher. With energy loss, final velocity is a smaller. Okay, it's a smaller value because some of the energy is being used up. So therefore, your kinetic energy decreasing, and it leads to the decrease in the velocity. Okay, so that marks the end of today's class. Okay, after you write it down, if no questions, then you may leave the class. Okay, kalau tak ada soalan, then you may leave the class.